Hi, Ashley. So here's problem I. A of t equals this expression here on the right. And what I like to do, finding derivatives of composite functions, is to take extra time to really break it down into tiny steps. And so here's how I would approach this problem at first. I would first say, let b of t equal cosine of t, and then and c of t equal, let's see, this is the sixth root of 1 minus sine of t. So we'll write it this way. Okay, so now we've broken it into smaller steps. Now, this isn't even the chain rule. This is even more basic. The derivative of a of t, or a prime of t, we can now say equals b prime of t minus c prime of t. Now the tricky one is going to be c prime of t, but we can do b prime of t very quickly. B prime of t, referring back to this, is simply negative sine t. So we're done with b prime of t. Let's just draw a box around that, and we'll come back to it later. And now let's attack c prime of t. So let me go to a new page. Okay, so we said c of t equals, forget that, 1 minus sine t to the 1/6 power, sixth root. Okay, so now instead of talking in terms of c prime of t, we're going to change notation a little bit, and I think you'll see why later. But I like, when I get to this point, I like to go dc of t over dt. That's what we're looking for. That's the same thing as c prime of t, right? Okay, but as you'll see, I like to use this form or notation for the next step. So, okay. So here's my approach to the chain rule. It's slightly different, but it's really equivalent to what you've been taught, at least the way they set up this worksheet. So what I like to do is define a new function, let u equal 1 minus sine t. Okay, that's it. 1 minus sine t equals u. So with that, we can make a little substitution. And so now we can say that dc of t over dt equals du, excuse me, that's not right. Let me back up. Let me back up here. So ct equals u to the 1/6. That's what I was trying to say. Okay, so now we can define dct over du. That's easy. That's just 1/6 times u to the negative 5/6. Okay. And what we also want to find now is du dt. Well, that's where we refer here. That's easy. du dt is negative cosine t. Now here's the catch. Now that I have this, and not the catch, but here's the secret for me that makes this, it helps me make sure I don't make a mistake. If we want to find dct dt, well, we ought to be able to multiply the following two terms, dc of t du, and then du dt. And the reason I like this is, first of all, we found this term over here, and we found this term, or this factor, excuse me, and that's right here. And if I think in terms of multiplying, I can see immediately that I'm doing it right, because I know that just like any other product of two ratios, if you just think of these as two ratios that you're multiplying, you can see that the du's cancel. So you're guaranteed that you're going to wind up with dct over dt. And what does that equal? Well, it's just the product of these two ratios. So it's 1/6 u to the negative 5/6 times negative cosine t. And now it's just a simple matter to go back and substitute for u. Well, what's u? U we had up here. So you would just plug 1 minus sine t in for u, and you will have the correct expression. You might have to, in some cases, there might be some further simplifications to make to get it into its simplest form, but you're guaranteed to be on the right track.